Hello my dear students, once again welcome to your online class. So today we will be continuing with the third chapter of your physics, that is the machine. So the next type of simple machine we have is a pulley. So what is pulley? So as we already know that pulley is a circular disc. Okay. So a pulley is a circular disc which is capable of rotating about a fixed axis, and this circular pulley has a groove around its rim. Okay, so groove means like when you see it laterally, you will see a pulley as like this. Okay, so it's a groove. Now this groove is for letting a space for the rope to move without slipping sideways. Okay, so the pulley is simply, it's a circular disc which is capable of rotating about a fixed point which is known as the axis, and then it also has a groove around its rim. So now coming to the pulleys, so there are two kinds of pulleys. Okay, so the two kinds of pulleys, the first one being a single fixed pulley, and the second one being a single movable pulley. So it's a single movable . Okay, so we have a single movable pulley and a single fixed pulley. So in your board exams, you might be asked to draw a single movable pulley or a single fixed pulley, and also you will be asked to derive the mechanical advantage, velocity ratio and the efficiency for a single fixed pulley and a single movable pulley. So let us try to draw a single fixed pulley and a single movable pulley, and also find its mechanical advantage, velocity ratio and the efficiency. So in a single fixed pulley, the axis of rotation, it remains fixed, just like the name says. So how to draw it? You draw one fixed base, and then we draw like this, or such like a T. Okay, and then we draw a pulley here. Okay, so this is how we draw a single fixed pulley. So this being the axis of rotation. So this A is the axis of rotation. And also what we do is, so we tie a rope, we pass a rope around its rim. Okay, so we have a rope here, and then we can apply here. So at one of the end of the rope we have a load L, and the other side we apply the effort E. Okay, and then on both the side of the string, let T be the tension acting. Okay, so the tension always acts upward. This is because of the Newton's third law of motion. Okay, so to every action there is equal and opposite reaction. Just like the load pulls vertically, the weight of the body acts downward, but whereas the tension acts upward. Same on the other side as well. So now to find its mechanical advantage, we have a simple formula. The mechanical advantage is equals to load divided by the effort. So here from the figure we can clearly see that the load is supported by one tension T, and the effort is also supported by T. So the T and T cancels and becomes 1. So the mechanical advantage of a single fixed pulley is 1, which tells us that the single fixed pulley is neither a speed gainer nor a force multiplier. But using this pulley we can obtain the change in direction of the force. Here we see that we can lift a load upward by applying the effort downward. Now coming to the velocity ratio, VR. So the velocity ratio is given by the distance moved by a foot to the distance moved by the load. Now if you see here, if you pull the rope with the distance of D, okay, downward, it's obvious that on the other end also the load will get raised upward by a distance of D. So thus I can write DE means when the effort moves a distance D, the load also moves a distance D. So cancels and becomes 1. So the velocity ratio of a single fixed pulley is also equals to 1. Now finally coming to the efficiency. So efficiency is simply the ratio of the mechanical advantage by velocity ratio, which is equals to 1 divided by 1, which is also equals to 1. So thus we can say that the efficiency of a single fixed pulley is equals to 1, or which is also equals to 100%. Okay, so this is the efficiency. So in case of a single fixed pulley, the mechanical advantage, the velocity ratio and as well as efficiency is equals to 1. Usually the efficiency is not equals to 1 or 100% generally, because here I did not consider the weight of the rope, I did not consider the friction of the axis, neither I I considered that these ropes are perfectly inelastic. Whatever rope we use, it is somewhat a little bit of inelastic. So that's why the efficiency of a single fixed pulley also always remains lesser than 100%. So now coming to the second kind of pulley, that is a single movable pulley. So as the name itself suggests, so the single movable pulley is a pulley whose axis of rotation is not fixed. Okay, so to draw it, I draw one fixed surface. Okay, and I put one hook here, I tie a rope. Okay, and then the pulley is here. Okay, so I draw a pulley and the rope goes upward. Okay, now here I have the axis of rotation which is attached with another hook where you can suspend a load L. Okay, so now we apply the effort upward. Okay, so both the sides let the T be the tension acting. So let us try to find the mechanical advantage and the velocity ratio of this system as well. So again, the mechanical advantage is equals to load divided by the effort. So equals to, now we see here the load, it is supported by both the strings. That means the load is supported by two tensions. So I'll write 2T divided by, now coming to the effort side, the effort is supported just by one tension. So it is divided by T. So T and T get cancelled and remains 2. So the mechanical advantage is equals to 2. Okay, so the mechanical advantage equals to 2, that means greater than 1. So it tells us that the single movable pulley acts as a force multiplier. So now let us try to find the velocity ratio. So velocity ratio is equals to the distance moved by effort to the distance moved by load. So now to understand this, what we assume? We assume that we are holding both the end of the rope, and when we pull it upward with 1 meter, so it is obvious that the load will also get raised by 1 meter. But here what is the problem? The one end is fixed and you are pulling only one of the end. So it means that if you pull the effort by 2 meters upward, only the load is raised only by 1 meter, because the 1 meter is compensated on the other side. Okay, so therefore if the distance moved by effort is 2d, okay, so the distance moved by the load will simply be d. So substituting this value in this, we get 2d divided by d. So d and d cancels and remains 2. So the velocity ratio is also equals to 2. Now coming to the finally efficiency, we know that the efficiency is the mechanical advantage divided by the velocity ratio, which is 2 divided by 2 also equals to 1. So therefore the efficiency is equals to 1, or which is also equals to 100%. Okay, so that is the basic difference between the single fixed pulley and a single movable pulley. And in this case also the efficiency remains lesser than 100%, because here I did not consider the load of the pulley. Okay, and neither did I consider the friction in the axis of the pulley. So this is very important from your examination point of view.